So we are looking at earth geometry. We're going to look at just few questions that normally come in our final exams. We have the 2023 final exam internal. But before we look at that, let's look at few things that we need to know in terms of earth geometry. Okay, so if we have our sphere or our earth surface like that, okay. Okay, so let's look at this earth surface which we have just drawn here. There are a few things that we need to know as we are about to answer this question. The first thing is to know first a great circle. Then the second thing is to know about a small circle and the formulas that are being applied in order to get these things. Okay. So a great circle, all points that fall along the same longitude. Okay? Points that fall on the same longitude are in a great circle. So when you look at this, we have this longitude there, we have this longitude here. So these points that are falling on the same longitude are in a great circle. So we have point B, we have D, of course, BD, BF, FD, AE, EC are in a great circle. So what's the formula for distance along a great circle? So distance along great circle, for example, BD, we can say is equals to theta over 360 times 2 pi r. Where the theta, since it is on the same longitude, the theta is the difference. Theta is the difference in latitudes. Okay? So the difference in latitude. Okay. You check if they're in the same hemisphere, you subtract. If they're indifferent, you add. Apart from the points that are falling on the same longitude, all points in the equator also fall under the great circle. So EF is also in a great circle. Okay, having looked at a great circle, we can also look at a small circle. Small circle, these fall under the same latitude. So they always fall under the same latitude. Now, the latitudes are which lines? These are the lines that are going this way. These are latitudes. So all those that are on the same latitude, except one, which is the equator. Remember, the equator is in a great circle. Okay, so all points in the latitude fall under a small circle. Like CD, we have CD. We have A and AB. These are in small circle. Okay. Now, what is the formula for distance along this small circle? So, like CD is equals to theta over 360 times 2 pi r cos x. Now, this x is this latitude on which these 2 points are falling. On what latitude are they on the same? Of course, they are on the same latitude x. So if it is 50, you put 50. Now when it comes to this one, the theta, when you look at C and D, they are standing on different longitudes. This one is standing on this longitude, this one is standing on the other longitude. So the difference between these longitudes will be our theta. So this one depends on the longitude. difference in longitude. So it's just the opposite. The moment you look at the longitude, same longitude, which is the great circle, the theta is always the difference in latitude. If we are on the small circle, which is the latitude, the difference is on the longitude. Having looked at just few hints about this, let's look at the question that came in the 2023 internal final exam. Okay, so we have this question here. The points A, B, and A, B, C, and D are on the surface of the Earth, as shown in the diagram below. Of course, pi is that. Then we have the shape there. The first question says, find the difference in latitude between point A and D. Okay. The second one, calculate in kilometers the distance between A and B along latitude 50 degrees, B and C along longitude 40 degrees east. Okay, so if you have this kind of a nature of a question, like the first question that they have asked, which is the difference in the latitudes between point A and D, you check. We have point A, which is here, point D, which is here. They just want to find out the difference between the latitude where this one is standing and the latitude where this one is standing. So you can see that the latitude is 50 degrees north, and then the other one is 50 degrees south. So if they are standing on different hemispheres, the other one is in the northern part, the other one in the southern part. So here you add. So what you are going to do is that, let's look at what we expect. So I expected the answer. Okay. So the first question is saying, find the difference in latitude between points A and D. So we checked and we found that point A, it is on 50 N, which is north, D, it is on 50 south, which is S. So what we are going to do is very simple. We are going to say, okay, our Roman numeral 1, since they are in different hemispheres, we are going to add. So our 50 plus another 50. So 50 plus 50 gives us 100 degrees. Okay. So 50 plus 50, that is 100. All right. Coming to question number Roman numeral 2. Coming to question Roman numeral 2. So what we are going to do is, it says, calculate the distance in kilometers between A and B along the latitude 50 degrees. The first question that you have to ask yourself is this, that is this distance that I'm looking for in a small circle or a great circle? That's the first question that you have to ask yourself. So I'm looking for A, B, which is from here up to that point. So I check they are standing on the same latitude, meaning this is a small circle. So what is the formula for distance along the small circle? So we are going to say AB is equal to theta over 360 times 2 pi r cos x. The x there, remember, it is the latitude on which they are falling. They are on the same 50 degrees. The theta is the difference in latitude. The other one is on 20, the other one is on 40. So if this is west, that is east, they are not in the same hemisphere. So we are going to add 20 plus 40. So our theta will be 20 plus 40, which gives us 60 over 360 times 2 times our pi. We are told to use 3.142 times our radius is 6370 times cos x is what? 50 degrees. The x, remember, is the latitude in which they are falling. Okay, so after that, we are just going to punch, which is 60 divided by 360, of course, times 2 times 3.142 times 6370 times cos 50 degrees. Okay, so it has given us 4288.366,109. Now, when you go on your question paper, the first front page, it says on the instruction, if the degree of accuracy is not stated, always round off to 3 significant figures. So we have 1, 2, 3. So I'm going to say 4, 2. The third one is this one. We look at the next number. If it is more than 5, from 5 going up, we get 1. So we're going to get 1 from 8 and add to this 8, giving us a 9. Then here we put a 0 in kilometers. So that becomes our answer there. So it's just a matter of putting the theta there, then later you punch on your calculator, the 60 divided by 360 times 2 times 3.142 times all those, and then you'll be able to get this value. Okay, looking at the third question. The third one says the distance B and C along longitude D 40 degrees. Just like we asked ourselves a question previously, to say, where is it falling? Okay, so is it in a great circle or small circle? So we're looking at B and C. So they are standing on the same longitude. And we say, if it is on the same longitude, that means it's a great circle. So we're going to say, okay, our BC will be equal to theta over 360 times 2 pi in r. Our theta again is the difference in latitudes. This one is standing on 50 north, this one is standing on 50 south. So we add these two, giving us 100 over 360 times 2 times, what is our pi? 3.142 times 6370. So the theta, remember, is the difference. Then the pi, we know we have been given, the r, the radius have been given. Please do not put a cos there because it is not in a small circle. So after that, again, we divide 100 divided by 360 multiplied by 2 multiplied by 3.142 multiplied by 6370. This gives us 1,119.1889. Okay, we round off again to 3 significant figures. We have 1, 2, 3. So it will be 1, 1, 1. Look at the next number, it's less than 5. So we cannot get a 1. So it becomes, we put 2 zeros here in kilometers. So that becomes our answer for the Roman numeral 2b. So here it's supposed to be Roman numeral 2a. This one is supposed to be a, Roman numeral b. So this is how it's supposed to be. Otherwise, this is how you solve this type of equation if it comes under FE geometry. That's what we expect from you. That's what we want to hear from you. All right. We look at the next question again under FE geometry for 2023. With this one, we're not given something that was already drawn, but we were just given so that we sketch and probably show the sketch. So 4 towns, A, which is on 70 north, 65 west, B, 70 north, 65 east, C, 70 south, 65 east, D, 70 south, 65 west, are on the surface of the earth. Of course, our pi is 3.142 and our R is 3437 in nautical miles. Remember, this is nautical miles, it's not kilometers. Sketch the surface showing all the 4 towns A, B, C, and D. It carries 2 marks there. So we are going to sketch it. We are going to sketch the surface of the earth showing all the 4 points. So this will be our sketch. Remember, it's just a sketch. So this is how it is going to look like. I do that. Okay, that is our north there, our latitude, another latitude there. Wow. So let's come to this point here. We have to check how many latitudes we have. So on the north we have only 70, that is the 70. On the south we have 70 south and this one. So we have only 2. So meaning I'll have 70 south and 70 north. On the east, I have 65 and the 65 west. So we have 65 east, then we have 65 west. Then I come and start putting my points. My point A is the 70 and the 70 north, 65 west. My B is 70 north, 65 east. My C is 70 south, 65 east, which is here, and D definitely comes in there. So what I've done there is I have sketched the surface of the earth, showing all the 4 points. Okay, that carries 2 marks. Okay, we move on to Roman numeral 2a. So, with Roman numeral 2a, it says calculate the distance. The key part here, nautical miles. Okay, AB along latitude 70 degrees. So our AB, which is that one, that is our AB. So AB is equals to theta over 360 times 2 pi r cos x. Why cos x? It's because it is in a small circle. So we are going to say our theta is the difference in latitudes. So 65 plus another 65, which gives us 130 over 360 times 2 times our pi is 3.142 times our r is 3437 cos. Okay, cos what? On what latitude are they the same? 70 degrees. So after this, so comfortably you get your calculator, you punch 130 divided by 360 multiplied by 2 multiplied by 3.142 multiplied by 3437 multiplied by cos 70, which gives us 2667.523442. Remember to round off to 3 significant figures. So this one will definitely give us 2, 6, 1, 2, 3, 7, 0 nautical miles. So that becomes our answer for Roman numeral A. We go to Roman numeral B, BC. BC is along longitude 65. So what do? We are going to say, okay, BC is equals to theta again over 360 times 2 pi r cos. No, we don't put a cos. The reason being that it's along the great circle. Okay, so our theta, the difference in latitudes. The other one is on 70, the other one on that, and then different hemispheres. 70 plus 70 gives us 140 over 360 multiplied by 2 times 3.142 times 3437. Okay, so let's do the multiplication. If you have your calculator there, you can punch and re-verify. 360 divided by 140 divided by 360 multiplied by 2 times 3.142 times 3437. Okay, this gives us 8399.26 422. I mean, choose 3. So we don't look at 3 significant figures 1, 2, 3. So when you look at 9, you can add to this one. When you get 1 from 9, adding to 9 becomes 10. You don't write 10, but you push another one to the next number. So this one becomes 4. So we are going to have 8400 nautical miles. So that is how we find the distance along great circle in nautical miles. The other way, if it is in nautical miles, we can say, okay, or remember in nautical miles, 1 degree is equivalent to 60 nautical miles. Okay, so if you don't want to use this method, if 1 degree is equal to 60 nautical miles, that is in a great circle, please. This is a great circle. If 1 degree is equivalent to 60 nautical miles, then how many nautical miles can 140 give us? So it's the same as saying 140 is equals to x. So we just multiply our x will be equal to 60 times 140. This is another way. When you multiply this, it will give us directly, without even rounding off, 8,400 nautical miles. So if you want, please, you can use this in a great circle.